Greetings! Today I'll be making LED lights for my fish tank, and what you see here is LED panels that I've made some time ago, a couple of months back, and I was running those in my tank as an experiment, and it was okay for some time. Now this, by the way, this was my idea of how I did it. So I literally took two pieces of flat sheet plastic, like the acetate, or I actually used laminating sheets of plastic, and I sandwiched this in between them, those two, and basically super glued and used a little bit of hot melt where the wires come in, and this way this was in a pocket, so it was waterproof. Now I could have used just waterproof strips for this, but those strips are salvaged. I didn't buy them, so I thought I might as well use those and you know, tackle a challenge of making this waterproof. Unfortunately it failed. As you can see, after about 3 months, the weak point was the hot melt, where the wires come in. This didn't last very long, no, didn't hold up very well to the test of time. A few LEDs have failed due to the water coming in. This one's a little bit darker, and here it's gone really messy. I've tried repairing it. Those two appear to light up just fine, but this one, I think that it's gone really dark, and I think it's the inner bond wire on the die that's actually gone, because when I press on the soft epoxy, on the yellow stuff in the middle, it does light up briefly, but it's not reliable contact. So I will be changing this. I haven't got any more of this, but I've got a strip of blue LEDs, so I'll stick the blue ones, just one row on both of them to make them the same. And yeah, another issue with this, when I first built this, was that this is quite a lot of LEDs. So that's 1, 2, 3, 4, 5 sections of 15, and those are 50/50 RGBs. So they've got 3 chips inside. So if we count those as 3. 1, 2, 3, 4, 5 times 1, 4, 5, 8, 9, 12, 13, 16, 17. Oh, 17 times 15. How much is that? I'm not too sure, but that's close to 300 LEDs. So yeah, this was getting quite warm, and when this is going on full blast, those two panels draw at 12 volts, and they will draw somewhere around 3 amps in total. So it does produce quite a lot of heat. And when this was encapsulated in a plastic, which is an insulator, this wasn't very good for the heat transfer. So basically that's why I think the hot melt failed, and that's why the water got in. And besides, LEDs don't like to get really hot. They're okay warm, but they don't like high temperature, and this was basically just in an insulated bag, so not very good. So I thought I'll rethink this idea how to make this work, and I'll make a video about this. So I've done a video actually when building this, but I haven't posted it, and maybe for good, because it didn't turn out so well. So what I thought would be a good idea to provide some, make sure it's rigid. So when the plastic, it was quite flimsy, and provide some surface that will transfer the heat away from the inside of the pocket. Now, by the way, you might ask, why would I do this? Well, because you can buy ready-made LED lighting for a fish tank, and yes, you can, but there's a really good reason to do this. LED lights for fish tank are extremely expensive, so I'm sure there is an opportunity for business there, because essentially all they are is LEDs. You just choose the correct LEDs and you know, stick them in some sort of fixture. I am sure that this can be done for less than, well, for a lot less than what they're selling them for. Maybe there is maybe the cost is due to the limited customer base, because not just everyone has got a fish tank, so the manufacturing costs are a lot higher than what it would be if it was mass manufactured. But nonetheless, it's a lot cheaper to actually pick up a soldering iron, pick up LED strips from eBay, and get the stuff done yourself. Now, couple of things to note if you buy this from eBay: when you make sure that the power supply is not it's actually isolated, not because some of them come with just a capacitor as a current limiting thing, and yeah, a couple of diodes to rectify the current, and that stuff is no good for a fish tank, because it's water, moisture, and yeah, it's not isolated from mains power, so that doesn't it's not going to be very good if you touch something in the wrong place. So yeah, just make sure the power supply is isolated, and if I was to recommend, just get the waterproof strips and use those, wrap them around something, secure them, wrap them around something metal preferably, and that's it. So you'd have your lights, and it's at least 2 orders of magnitude cheaper than buying the fish tank LEDs, that LED modules, because some of them go for ridiculous 300-400 quid, especially if you want to get some high power output. I'm talking 30, 40, 50 watts. They go crazily expensive. So yeah, so what I thought for this to fit my criteria, what I got is this. So I've got 2 pieces of acrylic. That will be the front, so those will be sitting around the on top of the LEDs, and for the back I've got I think that's 1.5 mil thick aluminium sheet that's still got the plastic on it. It's essentially the same size as the acrylic, so I will be able to stick this onto the aluminium, cover it up with this, and the gap that's left in between them, I purposely left quite a bit larger gap, not just a couple of mil, but I will just silicone the hell out of it, and yeah, this should hold pretty much completely. I'll just redo the wiring, because this is just plain ugly. But as I said, this was an experiment to see how that works, and yeah, that should be it. So let's get to it. Now, by the way, I might as well show you. This is insanely bright. So when I put it on full blast, as you can see, those LEDs are failing, and this one, if I just manage to press it the right way, or maybe not anymore. Oh, the cap came off. That's interesting. Okay, we'll have a look at that. But anyways, if I short this out, it will light up the remaining LEDs. But nonetheless, this is really bright, and I've got a strange LED driver over here that I can control the RGB 5050 chips, and choose different colors or a mixture of colors and whatnot. I was mostly running in this, so it's they are not outputting any green, and just blue and red. I would have run it on full with the green actually, but the problem with that was it was getting much too hot, so I never run it on full blast. When it's in this mode, it's ridiculously bright. I mean, it probably doesn't show on the camera, but it actually hurts my eyes when I look at it. So yeah. Now what I'm not noticing is this driver is still not putting out full power, because I am seeing that it's still being modulated, because I can see all this flicker. So what I'll probably do is, or I can do one of two things: either wire all LEDs in all the strips in parallel and just run them all on full blast, or connect more wires. Now, advantage of running them on full blast would be, there we go, back to normal. So I would avoid the thick cable going in and out. But I kind of like the idea that I could change the ambient color of the fish tank. Okay, so I've connected all the RGB strips just straight across, straight to 12 volts, just to see how that's going to look. And oh, okay, you know what, that does actually appear brighter. I don't know. It's still really bright, but what I'm noticing, it's getting warmer a lot quicker. So curiosity, how much what's the current draw on this? Okay, so I've got it connected to the power supply through the meter on 10 amp range, and I'm just going to probe onto the negative to see what's the current draw, and the whole emitter shows 2.37, 2.38. So this, as the LEDs get warmer, they will draw a little bit more, yeah, 2.4, just under 2.5 amps, so about the same as it used to be. But now I'm thinking it will probably be a lot easier just to leave it on full blast, and this will minimize the amount of wiring and the amount of messing about with this whole thing. Okay, I'll still think about this. Right, surprise. So what I've just noticed, and what I've noticed is that this is disconnected. Only positive is connected to the LEDs. There is no the positive goes in through the meter onto the controller over here, and well, not the controller, directly to the wire actually this time. And this is the negative. So if I touch that, that will flash the lights or switch them on. But right now it's not connected. So what I've noticed, I've put my hand on the table and it gave me a little tingle. So I thought, okay, hold on a minute. And as I put my finger on the resistors, so it basically makes contact, the LEDs light up ever so lightly. Let me see if I can zoom in so you can see that. Okay, there you go. Look at this LED. This is by the way still not connected anywhere. It's sitting off the bench. Now I'm gonna try to not to touch anything, just my finger, and there you go. You can probably just about see the, there we go, the red LED comes on. Oh, and the white ones come on too. It's even more visible. It's strange. Where where are the electrons going? Because I am sitting on a plastic chair with my feet off the ground, and I'm not touching anything else. The negative is nowhere to be connected. What's happening here? I'm quite puzzled. Now, when I got a tingle, I had the mat, the grounding mat connected to the ground ground point, and you can see. Actually, let's zoom back in. This is interesting. Oh, not that too much. There we go. So now, if I place my finger, you can see the red one comes up, but if I touch with the same hand onto the grounding mat, even the blue one comes on. Well, the green one doesn't want to come on, but this is quite visible. Oh, I can even touch with the other hand. So what I'm doing is just placing my hand on the bench, and that lights up all of them. So watch this. Yeah, that's well, it doesn't show over here. Maybe it will show in the actual video. But yeah, I'm puzzled. Why is this happening? If I touch the power supply to the ground, to the earth, nothing happens. So not entirely sure. Now I've disconnected. Let's see if the same thing happens if I just connect the negative. No. So when the negative line is connected, nothing happens. But the moment I connect, no. It was only the negative that was connected. I stand corrected. So this is negative wire. The positive wire is disconnected. So this is plus coming from the power supply. And yeah, this happens only when the negative is connected, and so this will happen anywhere. Oh, this one lit up, the green one. Yeah, so is that free energy? Have I just broken the laws of physics? I'm sure I didn't, but yeah, it's strange because, well, technically there is nowhere for electricity to go. So I am a little bit puzzled by this, but that's just a slight off topic. Let's get back to making this work. Okay, surgery complete. What I did is I removed one of the strips from the inside and moved it to the edge, and then I replaced 3 sections with blue LEDs, just so the whole thing looks symmetrical, and I've done the same on the good one as well, just so they look the same, just because I can. So now that's complete. It's time to move on to getting the enclosure ready. And how I'm going to do this is the backing plate, the aluminium one, the LEDs will go on top of it. So I will remove the paper just before I stick them in. The paper just holds it in place all together nicely for me now. And I'm going to use this. This is just a thin strip of what's it called? Foam board, I think. Yeah, foam board. So this is just 2 thin sheets of plastic, and filled up with foam underneath. This is flexible, and I've just picked up a couple of sheets recently in a craft store. But this will be great for this because I can make a border around the LED panel, and then when I sandwich it together I will have a lip around that I can fill up with silicone, and this is compressible, so it will allow me to squish it down to basically fill up all the gaps and whatnot. And yeah, that's my idea around it this time. So I'll get on and I'll probably just cut relevant sections and super glue them in place. I'm gonna leave a bit more space on this side because this is where the wire is gonna come in, so I want a little bit of extra silicone around here because this is probably the weakest point in terms of sealing it up. So yeah, I'll get on with this. And now it looks like this. So I've just super glued those borders in place, so I can have those LED panels inside, and I left a little opening here for the wires to come in. Then I should be able to attach the cable, put the acrylic on top like so, maybe super glue it so just so it doesn't move, and then squish it down, and once it's squished silicone it around the edges, and that should make a complete unit. For connecting to it, I found this, and that's what I'll probably use. This is like a alarm cable. It's a 12 core, so that will give me plenty of options, so I might as well keep the control of separate colors. And because I've got 12 cores, and just to make it easier for the current to flow, what I'll probably do, I'll probably use two cores per each color, and the remaining 4 cores I will use as the common, just the common positive, and those will be the negatives. I'll probably just rearrange them probably so they match the color of the LED and whatnot. And yeah, so I'll wire this up now, and that's all wired up, both panels. I've decided to put did I say that already? That was a while ago. I was busy doing something else in the meantime, but yeah, the blue sections that I've stuck in are in the middle, and I've added a few jumper leads. As I said before, I've got two cores per color, plus 4 colors for the common positive, and I've stuck each wire in different places, and they're bridged later on for each color. I've only bridged the common positive onto every pin on the front, and I've done exactly the same with both of them. So now that's all wired up and can be switched on. I've just got bearings over here, and I can switch on each color separately. Yeah, so it's nice and bright. Time to secure this wire in, probably with a little bit of super glue, and stick the top on, and then fill up the outer perimeter with silicone, and then get it stuck together overnight. And here they are. This is just after I super glued it together, so now it's ready to fill up the gap around with silicone and make it fully watertight. One thing, as I was putting it together, I decided not to remove the cardboard from behind. Reason being, it's not going to make a huge difference. I mean, the aluminium backing will still radiate some of the heat away, but I was more concerned with getting a short towards the aluminium backing, because in a lot of the places the tape has been patched up and whatnot, so this is going to be much more reliable. And I've added a strip of just electrical tape underneath here, again for the same reason, the wires, and sometimes they're a little bit longer and blah blah blah, because this is not serviceable once sealed. I'd rather have that in, but yeah, this is already a solid unit, so apart from not being watertight, this is fully usable right now. So yeah, let's get on with siliconing this in. Right, so now I've got both of them clamped to each other, acrylic side towards the middle, and it's in between two aluminium brackets, so it's getting squeezed moderately without too much pressure, but I figured it will be easier if I just apply lots of silicone this way, and when it dries out I can always use a blade to cut off the excess, but it will be a lot quicker to get the silicone on this way. So yeah, I'll move on with that. And mission accomplished. So there we go. That's the whole thing in still in F clamps. Oops. Yeah, I've just finished putting all the silicone in. It's a bit rough and whatnot, but that doesn't matter. When it all sets, I'm just gonna have to run a blade along the middle, in between two two acrylic sheets, and separate those out. Maybe tidy up the edge with a razor blade, and yeah, that's about it. So I've got to leave it to cook for a couple of days, just to make sure that all the acrylic sets, and yeah, that's it for this video. When this is up and running, I'll possibly post a short clip showing it in action, but as far as construction of this is complete. Unfortunately you can't see the finished product just yet, because it's got to stay clamped, but yeah, anyways, thanks for watching, and that was a fun build. So yeah, so if you like this idea or enjoyed the video, please do click thumbs up. I am making an effort to make those videos somewhat better, and yeah, feel free to subscribe. For now, take care.